Okay, if you clicked on this video, you probably have wires like this. These are the 9-volt wires from the 90s and early 2000s where the insulation just flakes off over time and will short circuit. Not great. Or maybe you're interested in making some of your own cables. This is a custom Power Functions 4-wire extension cable. This is 9-volt to Power Functions extension, and there's 2 different ways to make this cable. And you can also make a quick little jumper like this. And then of course you can just make new 9-volt wires that look great and function very well. Many of the projects I've done on this channel have heavily relied on making these custom cables, and it opens up a ton of possibilities. I'm not going to go really in depth with that. I had planned on kind of having an intro to this video, but I'm just going to get right to it with repairing and making wires. So I'm going to put some information in the front of this video, so make sure to watch this intro because there's going to be, I'm not going to repeat myself. After that, there will be chapters for each type of cable that you might want to make. But before we get to that, let's talk about supplies and tools. Okay, so firstly, let's talk about wire. This is the most important part of the video. I have been making replacement cables for many years. This is a train cable I made years ago. Not only does it look like crap, this wire isn't great to work with. This is speaker wire, and the insulation is very tough. And that's not a good thing for what we're going to be doing today. If you know what the inside of these connectors look like, they have blade contacts that pierce into the wire. Same with these, same with Power Functions. And you need a nice soft insulation. This is silicone insulated wire. It's very flexible. It can kind of be trained into different shapes. It works very well. I buy the 6 conductor wire and then just split it off and run either 2 or 4 wire for Power Functions. And I'm using 24 gauge. This is the wire that I've been using since about 1.5 years ago when I started all this, when I found this wire and made my first tutorials. It's a little bit expensive, but it is the absolute perfect replacement wire. I've had people ask me about other speaker wire or phone wire or different things. I would not waste my time with that because the way you're going to make these connections, you're going to pop these connectors together. Same with Power Functions. And if it doesn't make contact, you've got to pop it all apart again and start over. Ask me how I know. I've been making wires for 10 years, and when I found this wire, I had to let everyone know. This is something new here. This is actually from AliExpress, and I'll have links to this wire as well. So if you're not on a time crunch, if you want to save money, this wire can be ordered from AliExpress. It's a different brand, of course, but to me, it looks the same, should perform the same. And look, I'm extremely critical of third-party products or store brand things because I've been told my whole life it's the same thing. And in so many cases, I'm like, no, this is not. So this is what I would recommend. I think this is the most economical way to get wires, to get the 6 conductor and split it apart into what you need. That also enables you to make a Power Functions cable and not have to use this one with the gray stripe. I do use this gray stripe in certain areas. It can be handy, or I think you could probably clean this off if you really tried to. But I've always kind of stuck with the 6 conductor, and they have different size rolls. You can just get 2 wire for both of these, for BNTechGo or for the AliExpress. So it just depends on your needs, depending on how much you need. Once you get started, I think you will find more uses and want to make more cables. Now let's move on to tools. Okay, so firstly we're going to need a screwdriver. I use an iFixit kit. You certainly don't have to. I have one of the smaller kits upstairs. This is absolutely not sponsored. It's just a product that I use and I like. And like I said, I've purchased multiple kits. I have a kit at work. I have a smaller kit upstairs. I can't tell you how many multi-bit screwdriver sets I've had. This is the only one I would recommend to anyone. So this is a 2.5 millimeter flathead bit, and that's pretty much the main thing you're going to need. It fits nicely into the grooves back here to get these apart. I'll show that in just a minute. And then inside of a train connector, you will need a Phillips head, a small Phillips head bit. It doesn't have to be anything exact. That's pretty much it for that. You're going to need a way to cut the wires. And with this specific wire and insulation, I would recommend scissors over wire cutters. Just in my experience, they seem to cut a little bit better. And then we're also going to need to be able to test our cables and make sure we're getting proper continuity. So we will use either a multimeter, and then you can just test your wire as you go. If you make a lot of cables, you can use a wire tester like I've made here. I do have a dedicated video on this that shows how to build your own. So this is a short circuit test. So if we were to short it out, the red light will turn on. And then we have a continuity test, and it tests each wire individually at the same time. So if we only get one, we only get one light up. If we have both wires making continuity, then both light up. So that was a fun project. It's pretty simple to make your own, and if you're making dozens of cables like I do, this is well worth the time investment. This was a little bit crazier. This is actually to test power functions cables. So we can do that very quickly here. This is an RCX, the first Mindstorms product for home use. And you can see the lights kind of chase. So you get 1, 2, 3. So we're getting ground from one of these wires, and then the other 3 go to each light. So if no lights light up, if 2 lights are lighting up at the same time, anything other than this, you know you have a bad wire. And now let's look at the connectors. Okay, so this is my bin for parts when I'm making and repairing cables. I have lots and lots of sensors. These are light sensors. For these connections, I just solder. I've covered that in a previous video. If you're comfortable with soldering, you probably already know how to. These are the 2 pieces for a power functions cable. It's a bit of a pain to get these apart once they're together, but you can order them just like this from AliExpress. I will place a link in the description, and make sure to read the text that goes with it. You have to set the color to what you want to buy. It shows the wrong picture when you click. It's extremely annoying. That's why I don't like AliExpress very much, and I don't like to place those links, but it's the only place to get power functions connectors. But I will have text to make sure you get to the right product. And if it changes in the future, please let me know, and I will update the description. It's just one of those weird things. So here we have 9-volt connectors. So some of these are already taken apart. The only place to get these is from original 9-volt wires that I've found. And I have been looking, and if you find anything, be sure to let me know. You can leave a comment or email me, because I'd be very interested in a third-party 9-volt connector, because they don't exist at this moment, as far as I know. And then, of course, Lego did have... well, I don't have any blue here, but they did have yellow connectors. Blue, and then actually if you take apart like a Technic Control Center, you can get a red one. Those are pretty cool. And then of course we have the train connectors. So you'll need 2 for a 9-volt train connection. They also have a ferrite choke, which I have one left there. That's maybe optional. I have made cables without them, but you might as well. Okay, so from here, you can choose the chapter below and go right to the type of cable you're looking to make. In order to streamline this video, I'm not going to show the same thing more than once. So the first chapter coming up will be on the 9-volt connectors, making a 9-volt to 9-volt cable. So if you're making an adapter cable, you can go to the next chapter for the 9-volt connector, and then you can go to the power functions and make that cable. I'm just trying to get this all into one video and make it nice and easy for anyone trying to get the information they need. Okay, to start, we're going to make a simple 9-volt to 9-volt connector. If you're making any type of cable that uses a 9-volt connector, start here. We'll show you how to get them apart and not do any damage, and make sure you get a good connection when you put them together. This is a 20 length wire. So we have 1, 2, 3, 4 studs on the connectors, 16 studs in between. So that's how they will be listed on BrickLink. So I'm just going to assume you want to make one exactly this length. Maybe you have a set and you're replacing it and you want it to be the same length. This is how you could do it. You know, use a base plate to get your wire length right, or you can just take the old wire and use that. Okay, so let's get this apart. So what we're going to do is we're trying to get these tabs to unclip, and they're on both sides, but we're only going to focus on this side for right now. Again, flathead screwdriver. You want to just work your way under it nice and easy, and then twist clockwise for this side. And you can see it's already pushed out on there. Now we do the opposite on this side. And we're going to go counterclockwise this time, work our way under, and then just twist it out until it starts to pop out. And you want to be careful with this. You don't want to overdo it. It's very easy for this piece of plastic to break away. So I've got it pretty much started. I'm going to, this is why I use a 2.5 millimeter. You can start going under like this and push it up. So yeah, this side popped out. Then you can go in the center here and just pull it right off. So this is the bottom side of the connector, and this is the top side. So I'm just going to pull the wire away. And a lot of times you'll have residual pieces of insulation in here. You just want to kind of flake it away and get it out of the way. This one came out nice and clean. Now we have these blade contacts. Hopefully they're going to show up in the video where you can see, but I'm going to take my screwdriver and just straighten them out. So you can kind of go from both sides and straighten it. Sometimes I'll go between them like this because they tend to go outward when you pull the wire out. So I'm going to go like this, just a little rotating motion to push this one up, this one down. And then on either side, maybe push them in a little bit. It just depends on how the wire came out, but you just want to get it nice and straight as possible, and make sure that like these two, one's not pushed up and one's pushed down, because then the wire might go in crooked and then cause you some issues. So I'm happy with that. So I'm going to take the bottom piece and go ahead and stick it onto the base plate. We're going to take some of our wire. This is the AliExpress wire, and what I'm going to do is get the length that I want. So I'm going to get as long as this, a little bit extra, because it actually is going to fold a little bit inside of the connector. That's close enough for me. I don't worry about getting it absolutely exact. Again, I use scissors to cut. It gets you a nice clean cut. And I'm not going to use the side that has this gray stripe. I'm going to pull from this side, and it just comes apart like string cheese. So it's very satisfying. And you can see it's got a curl to it. If you just do that number, you can get it nice and straight. So from here, I like to get a little bit of overlap on this side, because we're going to push it into the recess in the middle there. So I just take my screwdriver. I'm not puncturing through. I'm not pushing very hard here. I'm just trying to get the wire pushed in. Pull this side over. And again, this is another strength of the wire we're using, that it is very easy to train and make it keep its shape. See, I'm not even holding it and it's remaining in place. Not perfectly, it will come up a little bit, but that's quite good enough. Also, if these are very old, make sure that these connectors are nice and clean. I have had ones that were completely green with corrosion, things like that. If they are, you want to go about cleaning them, which maybe I'll do a video in the future. I have heard of a couple methods online, but I haven't really done much testing of my own. And once you get it nice and ready, you just put your connector on, and in one smooth motion, push it down. Just like that. A brick separator is nice to have. It makes it a little bit easier. And you'll notice it's kind of bowed out on both sides. So I go on each corner and make sure those clips go into place. Perfect. Now, it's very important to test right now before you put both ends on, and make sure you have a good connector. So we can use a multimeter to test. It's a little bit of a pain, and I'll show you why I use my tester that I use. So I'm just going to hold it. I'm not going to strip these wires. I'm just going to kind of hold it to the wire. Okay, so that side has a connection. Now, while you're on the same wire, test the other side, and that will make sure you don't have a short circuit. We don't. Now we need to test continuity on the other wire. Perfect. Now you can see that's a bit of a pain. That's why I went through the trouble of making this. So we can test that. We don't have a short circuit. If we did, oh, come on. The red light will light up. And then we can actually just use, you have to go to this other connector, the ends of the wire and push them against the connector here. We have continuity on that side, flip it over, continuity on that side. So that's why I went through the trouble of this. It literally has saved me hours of playing with these. Unless you have 4 hands, this is going to be much easier. This is a known good side of the connector. You can take anything, a 2x2 plate or brick or tile, whatever you want to put on there, put something on it so that you know that side is good, just in case we have a problem with the other side of the wire. So now I'm going to pop this other side of the connector apart here, and then we will put it on the other end of this wire. Okay, so now we have the other side snapped in. It gave me a little bit of resistance when I snapped it in, which makes me think I could have a short circuit, but there's only one way to find out, and that's to test it. Okay, so let's test this side first. This multimeter is not the best. I don't have good connections on it. That's fine. Now we'll test for a short. You can test it on the same connector or across the connectors like that. No short circuit. Come on, I hear it. Okay, so we've got a connection. It's not great. Let me take a look at this wire. Oh, see how dirty it is on that side? Even though that side looks a lot cleaner. I did not notice that. So that's something I'll have to clean up. But again, if we take our tester, it would be literally this fast. No short, continuity on both sides. You're most likely going to be using the bottom side of the connector more often than using the top. But still, I need to take this and get that cleaned up. So that's the 9-volt connectors. Now let's move on to making train connectors. All right, hopefully I get a good take of this. I only have one of these connectors left. These are getting crazy expensive. $50 on eBay for one that looks like this, with the wires just rotting away. Just kind of crazy. But we are, I believe, on the cusp of FX Bricks. They are going to be making a replacement 9-volt track connector, and they can't come soon enough. But for now, I got your back. Let's get it going. So I'm going to keep it in the bag here. Again, this stuff is flaking all over the place. So I'm just going to cut the connectors off. Before we do that, let's do a little bit of research here. Oh, this is going to get everywhere. Okay, so this is basically like the wire is straight. Now we've got this one going to the left, studs up. This one's going to the right, studs down. It's extremely important. That's the only way that it will work with a 9-volt track. This is the orientation. This is the spacing. So let's see what that is. We've got about 16 studs in between them because you want enough spacing to go around the 9-volt track. And then from there we have our ferrite choke, and it's about, about an inch away from the first connector. So get this back in here. Get this cleaned up. Okay, so once you know how these go back together, I would just cut the old wire off before you start working on them. And it just makes for a much cleaner process. So the only time I will keep the old wires connected is basically for a video like this, so you can follow along. Otherwise, I have stacks of these connectors like this. I just cut the old wires off and just save the connector. Now, when you're starting out, I guess it's best to start with the 9-volt connector part first, but you do get to choose the length of your wire. If you go very, very long with it, maybe you could have some issues with voltage drop. I've used extremely long ones, never had a problem, but that's just across like from my kitchen to my living room, where if you're in a convention and you're going down multiple tables very far, maybe it could be an issue. I'm just gonna make one about like that. Really a bit short, but you can always extend them with other 9-volt connectors. We've already covered this in the last chapter, so I'm just going to speed through this. Okay, so now we have our wire. We've got continuity between both sides and no short circuit. Next, you're going to need to do your ferrite choke if you plan on using it. I'm sure you get a lot of opinions if you ask if this was even necessary or not. I'm not even going to offer mine. I tend to use them if I have them, just to add a little bit more authenticity to the cable, I guess. Getting these apart is an absolute pain in the butt. I don't really have a lot of advice here, except just keep working on it both ends and trying to get it apart. I haven't really found the kind of perfect way to get these apart. And be careful with a screwdriver like this. It is possible to just jam your fingers. Ask me how I know. So be careful. Yep, and that's how you get your finger. Okay. Got that side. Okay, we're back with a Band-Aid. Again, please be careful when doing this, and I am not responsible for any damage you do to yourself in the process. Well, I just broke the connector off, but that's fine. 3 out of 4 is generally what you get with these. And you can see the wire, it just wraps around it. So let's get all this crap out of there. And again, this needs to go on right now before we put on the train connectors. So I'm going to run it through once, wrap it through like that, and I'm going to leave this loose like this for a while. That will be the last thing we do, is to tighten it up and then snap these together. So now we can do our train connectors. Okay, these are definitely a pain to get apart. Switching from my 2.5 millimeter flathead to a 2 millimeter. And you've got 1, 2, 3, 4, 5, 6. So you're never going to be able to get all 6 at once, in one motion. I just start with 1, and you can see it pushed out a little bit, but it's probably going to pop back in. But keep working on them. One set at a time. And then see, it's already starting to pop completely out. You can like kind of shave a little bit of the plastic off. I never worry with that. I think we've got all 3 unclicked from this side. They might click back in once we start working on this side. But it's one of those things, you just kind of work it out little by little, and then you can also go in that hole there, and it pops apart. So let's do one at a time here. This is your blade contact, and you'll notice it's only going to connect to one of the wires. And that's why you have to flip the other side so it goes into the other wire. These are generally pretty good about not getting too bent out of shape when you take them apart. Now let's grab a small flathead tip, and you've got a small flathead, Phillips head screw here. Remove that, and then what you can do is use the wire, don't lose that screw, to pull this out. Generally, I like to have a little more wire than this. I kind of cut it too short because that's what helps get this red piece out. So there, we don't have any much wire residue in there, nice and clean. And then take that off of here, and you'll notice the rubber does like to stick. It's been under a lot of pressure for many, many years. So we can take a flathead and just kind of clean that up. And don't get your finger. Okay. So I'm going to start, actually what I'll do is start with the far end, just to make sure we get everything right. Okay, for the far connector, did I point to these earlier? These are the blade contacts right there. They look pretty straight, pretty good. But I like to start with the blade contact going that way, because the other side of this is just going to be loose wire. So we want to make sure we're going to get a good connection. So just like that. So we'll go ahead and flip it over, and then use this red piece of plastic to get the wire in place. Okay, get that nice and snug like that. And then now we'll just snap it back together. Wow, I got that perfect where it's nice and flush against the side there. And now that we've gotten that far, let's do a quick sanity check. Make sure we're getting continuity. And nothing on the other side, so we are good. Now let's do the other side. Okay, so now we're getting ready to snap these together. So let's get all this gunk off here first. And go ahead and just snap that down like that. Pull your wire straight. We were looking for what, 16 studs between them. Again, make sure this wire is straight. Oh, wait, I'm off the camera there. So yeah, 16 studs in between is what the original cable had, so we'll do that again. I'm backwards. Check it out. Studs up, studs down, but it also has to be rotated 90 degrees. Let's give it a little bit of slack, and then a little more. And then start pushing that in, and then get our screw in. So we've kind of used up our slack there. We're a little bit less than 16, but it's just fine. You don't really need an insane amount. Now pull your wires nice and tight on either side, and go ahead and snap your connector back in. If you don't get that on the first try, you can always just pop it back apart and then just reseat this bottom part again. Now let's do a continuity test. And no short circuit. So this is a good train wire. Now all we need to do is finish this part up here. So I'm gonna pull it a little bit that way and just pull the wire tight like that. And it is kind of a tight fit when you try to get this on. I can't remember if I did the wire down or to the side. Again, I've only made so many of these, and it's not like I can just go out and buy a bunch more since people are charging $50 for them. Which, yeah, I mean, they're getting rare, hard to find and everything, so it is what it is. Just like that. And that is a completed train wire. Again, this section could be much longer. Remember, you need a little extra slack because you're going to use some of it up in the connector and the choke. You could also put a power functions connector on this side if you wanted to, for whatever reason. And just quickly before we move on, if you need to repair sensors, you know, just cut the wire here, give yourself enough slack, and then do some solder and heat shrink. If you want to see that done, I have done that in a previous tutorial. Just make sure you don't cut the wire from here too short, and make sure it doesn't get tangled up, you know, the two wires together. Make sure your strands are coming out just right, where you don't have a short circuit. You can see I've done lots of these, but this was with the old wire. These need to be redone. I'll get to it eventually. And from here, we'll get into power functions wires, extenders and adapters, and everything you need to know about that. Okay, so now we're going to look at making power functions cables. First, we're just going to make a straight through extension, and then we'll make some adapters later. The most important thing to remember with power functions cables is that these need to be the reverse of each other. If you've ever noticed, if you take an NXT wire, you've got the clip going up there, pull it straight. On the other side, the clip's going down. That's going to be very important. And so this is a very long cable, but if I were to stretch it all the way out, one connector would be up like that, and then the other would be flipped. The reason for that, we've got 4 wires, or 4 connectors. If I'm not mistaken, I think this is ground, this far one is 9 volts, if I remember correctly. And then these 2 in the middle, which are the 2 middle wires, are what actually run motors. I have talked about this more in previous videos, so I probably will link that below. But this negative and positive, the outer 2 wires, that's what powers a servo motor, or an IR receiver, or an S-brick if you have an S-brick. So that's why these connectors have to be flipped. And I'm actually going to use the scrap piece from when I made the train connector, because it has this white dashed line on it. So we'll be able to tell that we flipped our connector just right. So this is what you'll get from AliExpress if that's the route you go. I guess you can pop one of these apart from an official LEGO device or from a third-party device that has one of these plugs. They're a bit tougher to get apart. They do have 6 clips instead of just 4 like the 9-volt connectors. But you'll see they work the same. You've just got these blade contacts on either side, and it is very important to get all of them to make proper contact. Otherwise, maybe the bottom of the connector would work, but not the top, things like that. So I'm going to start with the top because it's just a little easier. It just kind of fits in there better to get started. And you want to get it kind of pushed in here and get it centered. And when everything looks right, just go ahead and start pushing down. You can even use a screwdriver. You don't want to bend the pins down. That's very important. But you're just really trying to get it started so it stays in place. Once you've done that, take the other side and just pop it on. And then where each of the clips are, you'll want to push down with a screwdriver or something just to make sure everything's getting seated properly. Okay, that looks good. These, whatever these are called, it's a tile plate something hybrid. Pretty handy for these connectors because they're not just going to stack onto here, or they will, it'll just be crooked. So for this we will need a multimeter. Set it to continuity test. And since we can see this white dashed line is going to be this connector here, so we'll hold it there, and then we need to touch it to the dashed line on this side. We've got continuity, and we don't have continuity on its neighbor because you want to look for shorts as you go. So let's just keep going down the line from there. Good. 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 Now again, this is the known good side. Go ahead and throw something on there just to make sure that you know which side is, if you have a problem later, you know which side to pop off and start over with. Now let's do the other side, and we're going to have, this is studs facing down, so we're going to have the wire facing up. So if we do it like this, they are going to be flipped from each other. Again, extremely important. So that's why I say it so much. So we'll just kind of get it started. You can really just with your finger, just make sure it's in place good. And let's take the other side. I kind of went at an angle. I don't know if I like that or not, but let's try it. Okay, now let's see if we got continuity. Good, 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 good. And then also, oh, we have a short circuit between these two connectors. So I'm pretty sure it's going to be on that side. So I'm going to see if I can get this apart. Yeah, it's coming apart pretty easy. And we'll kind of do an autopsy and see what's going on inside. So those all look straight. Those look straight too, but I'm wondering, this is the AliExpress wire. It's possible that's a little bit wider than the BNTechGo wire. But I wanted to try this wire out. I've had some people ask about it. I'm just going to try, well, first, no short circuit, so we know it was on this side. Get nice and straight. Okay, let's try that. Okay, so I don't think we have a short. Okay, now you need to test the underside. Normally I have a plate to put across these. What do I have here? Why not a touch sensor or a light sensor? And then we're going to do the same thing we did on the top, just on the bottom. And what I'll usually do is test one, move to the next one on one side, and that test for a short, then test for continuity, then test for a short, continuity, short, continuity. So this is a good power functions extension cable. And again, you can see we've got the striped line on the top here, and it's on the bottom on this side. Extremely important to make sure you'll be able to use IR receivers, servo motors, any of that kind of stuff, and make sure it has the proper polarity. Okay, now we're going to make some power functions and 9-volt adapters. So in this case, this is a 9-volt connector on the bottom, and it's actually going to the outer two connectors here. So this is a simple way to power a power functions IR receiver from a 9-volt source. It could be a 9-volt train regulator, a DACTA control lab, or 9-volt battery box, anything like that. But polarity is going to matter with these 9-volt connectors. If it's turned this way, it'll be one polarity. Turn it 180 degrees, it'll be another polarity. And 90s actually change it too. So if it doesn't light up, just flip it around, it should light up. I don't think you're really going to damage it by testing it one direction first. I've done quite a bit of that. That's how I test to see if it's the correct polarity. This is a much longer wire, and if I'm not mistaken, it's actually going to the inner two wires here. So this would be for running like a power functions motor from a 9-volt source. Or you could have this connected to an IR receiver on the output and have this going to a 9-volt motor. So this is different from, in a previous video, I made an adapter and actually folded the wires inside the connector. So the left two contacts were together and the right two contacts were together. So that works fine for powering an IR receiver or powering a motor. The problem is the reverse if you want to use a power function source like an IR receiver to power a 9-volt motor. That would have created a short circuit. So I did make that mistake. And it's also a much more difficult cable to make. So we're not going to worry with that today. Although it could be used if you want to control a servo motor from a polarity switch powered from a 9-volt source. Kind of a, I'm not sure that many people are using that use case. I have. But if you do, you can look at my previous video to see how I did that. But it's literally the same thing, just folding the wires on the inside. So I have two 9-volt pigtails ready to go. I've already tested these. They don't have shorts and they are making continuity. So I'm actually going to do it upside down. This is the one that has the dashed line through it. So I'm actually going to split these wires apart. And we're going to have to do these manually to get them to slot in, which is a bit of a pain, but not too bad. It might have been easier with 2 screwdrivers, but basically we're going to split. We're not going to use the 2 middle ones. We're only going to use the outer ones. And you need a little bit of wire. Well, no, not really. When you throw the bottom on, it's going to go between those two. So yeah, that should be fine. So let's. I can't find my good pliers, but I'm going to try to push on either side of the blade contact. Well, that kind of worked. I wish I could find my good pliers right now. So it's not perfect, but we should be getting contact to those. We can actually, without doing too much moving around here. Let's test it. And it is getting continuity. It's not, yeah. So that's fine. It's just because I'm not going to get a great connection. And these pins can push through, so you don't want to put too much pressure, especially if you're testing it like I just was. Then it's probably better to just go ahead and pop it together and then test it. Okay. And this should be a lot easier to. Yeah, this is much easier than if you have all 4 wires. Okay. Let's give it a quick test. Yep. And then don't forget to test the other side. It's not really a big deal on these because it's the same electrical connector. So you can test this one on the top, but the power functions you want to test on the bottom. Yep, and perfect. So I can connect this to a 9-volt power source, and then I'm able to power an S-brick IR receiver using this adapter. Now for motors, again, we're going to use the inner two wires. So you don't have to split these apart if you're using the right wire. I'm just going to get it pushed down. Really just enough to get it started is generally okay. And then let's go on with the other side. And let's see if we got it. Okay, so I got interrupted while I was filming this, and actually filmed another segment fixing the wrong cable. But we're going to get into troubleshooting a bad cable. There's something wrong here. So I've got continuity on one side. Yep, that's good. But I'm getting nothing on the other side. And it's actually the same on the bottom. So let's try to double check that. So that side's good. Nothing on that side. So since it is the top and bottom of this connector, I'm actually going to take this connector back apart first. So it's the same procedure as before. Just kind of work at it there, pop that side out. Okay, so we can kind of look at it here. It looks like there wasn't quite enough wire this way, if you can see, because that's where the contacts actually go in. So just to be sure, I'm just going to cut this segment off, and we'll just kind of start over with that side. So like I said, I'll pull this where you can see it. I wish I had a better camera for all this. I always leave a bit of overhang here to make sure that that doesn't happen, because it does get kind of pulled into the center channel here, and that can cause issues. And that's why I always push it in here first, so I should be able to see if it's going to have enough wire. I'm going to go ahead and straighten these a bit. Not much, they're not too bad. Let's go ahead and try that. All right. All right, now let's try it. So far, so good. Very good. And just while we're here with the troubleshooting segment, I'm going to show you how to take these back apart. It's not as easy as the 9-volt side, but it is certainly possible. And I just kind of start working at it. You don't really try to pop it out the first try. Just try to work on a little bit on this side. It won't feel like you're getting anywhere, but you probably are. It's kind of like the train connectors there. So okay, that felt good. Go back to the other side, keep working it. And then once you've got it kind of out of the clips there, you can go in from the end here and just pull it up. Well, almost. Let's get a little more, yep. Well, this one's being a little bit stubborn. But yeah, you can pop it out. You can make sure these didn't get bent over. Make sure the wire's in a good spot. You know, it's not pushing into the other contacts. If you have a short between two of the contacts up here or on the bottom, this would be where to look and make sure it's only going through the contacts you need it to go through. But everything looks good there. When you pop it back in, it actually goes in very easy because it's already kind of, I guess, stretched out a little bit or something. That's how you would go through troubleshooting a cable. So I hope you guys found this helpful. This is the video I'd like to have shared in the future. The original tutorials I did almost 2 years ago. And they were a bit rough, and I feel like this one was a little bit better, and I've kind of learned more tips and tricks along the way. So I wanted to start with something fresh. If you find this kind of stuff interesting, making custom cables and big Lego projects that rely on these kind of things, you'd probably be a good fit for our Discord server, which is linked near the bottom of the description below. We've got a really good group in there, train builders, but not just trains. We've got people that are much better at programming than I am, people that know more about electronics than I do. So we've got a really well-rounded group there. So feel free to join if you would like. And if you want to help support the channel, you can join our channel memberships. It's $2 a month to get early access to videos at the lowest tier, and that definitely helps a lot to fund these kind of projects. So thanks for watching. We'll see you guys in the next one.